Hey, okay. I just want to cover overfitting in this video. So this is our graph and these are our points, right? These are gonna be really small, right? But these are our blue points, okay? These ones, right? You get the point. And these are our, oh jeez, those look like lines, okay? So these are our red points, right? And like that, and so on, right? And so as you can see, our blue is like it's in this, it's like that, right? And hold on, let me put these here too. And let's just say we have an outlier of 3 blue lines here. I mean, sorry, not lines, but dots. Right, and the red keeps on going. So a good line would be something like this, right? Would be something along this right here. Actually, let's make these blue, right? So our function is clearly growing in this line, right? And we have 2 blue outliers, and this is a good line, right? The purple line, that's a good line. It's just right. Now, what overfitting may look like is it may look like this, right? Instead of this line, we might go up, but then we might overfit our data and go like that, right? Now, this could be anywhere. We might have an outlier here, and our green line might go like that. But the point is, our function is obviously not growing like the green line, right? You can see these are just outliers. These are random. If we had an outlier here, and our line fits our data like this, right? That's not right. So, and this is why the name high variance is there, right? Because when you make your predictions, there's going to be a high variance between correct and incorrect. So you might get a correct answer on the next prediction, but you might get an incorrect answer on the next prediction because of this line, which assumes your function is growing like the green line, but it's not. So that purple line, that's just right. Another thing we might have is actually no, I'll cover that in another video. But this is the idea of overfitting, and one way we can fix this is with regularization, right? So we regularize, right? And we have L1 regularization, we have L2, and let me do the L's capitalized so it doesn't get confusing. And we have dropout, and we have other forms of regularization, but these are the main ones you're gonna use. And what they do is they try to minimize this overfitting, right? So maybe our line will be fixed to that, right? Something like that. Let me do that in yellow also. So after we apply regularization, our line might look like this. Maybe maybe it will look like that, right? It won't be super perfect, but as you can see, it's gonna way better actually approximate the way that our function is growing, right? While instead of overfitting, our predictions are gonna be more accurate because we're assuming our function is growing that way in kind of a, I guess you can say like a half circle motion, right? So that's the point of regularization. But I just wanted to show you overfitting here.